Few minutes today and talk about how to plot graphs using Vernier's graphical analysis software. In physics, we're going to be plotting graphs a lot because graphs are the tool that tell us the relationship between variables. We need the graphs to be able to plot the best fit line, and the equation of that best fit line is typically what we're after. That tells us how the variables are actually related. So for my example, I'm going to be using this data out of the assignment in Physics A, the first assignment, graphical analysis of data, and I'm going to be plotting how metal temperature and electrical resistance are related. When you first open up graphical analysis software, it will look like this. Now this software is pretty powerful. It can do a lot of things, but in this course the only thing we're going to be using it for is manual entry of data. So I'll be clicking on this right here. I do recommend that at some point you go over here and click this user manual link and read through the actual manual for the software, because it'll tell you everything that you ever wanted to know about graphical analysis, how to do all kinds of analysis, how to collect data, do a lot of things that we won't be doing. So if you ever have questions, you can always click on that and it will explain how to do whatever it is you want to do with the software. But for our most common thing, we're just going to manually enter software. So I click right here on the manual entry, and when the software opens up, it will look like this. You'll have a window that shows a graph, and you'll have a data table. Now they may not be one above the other like I show right here. I had to change my screen just a little bit so I could show both my word processor document and the graphical analysis document at the same time. But you'll have these two parts. They may be side by side, they may be one above the other. When you plot a graph, remember there are certain things that you always want to happen. You always want the independent variable to be on the x-axis. You always want the dependent variable to be on the y-axis. You want those axes to be labeled correctly. You want the correct units that the data was measured in to be shown. And you want a title for the graph. To start with, I'm going to set up my data table here, and I'm going to put titles on it so I can keep track of everything. Now remember the standard way of showing data. In a table like this, the first column is the x data, or the independent variable. The second column is the dependent variable, or the information that goes on the y-axis. If I click these three little dots, it will give me the column options, and that will allow me to change the title. My x-axis here, since x gets the independent variable, I'm going to go ahead and put in the variable, which is the independent, and that's the metal temperature. And when I hit tab, it jumps over and I can put in the units, and metal temperature was measured in degrees Celsius. When I click apply, notice that it not only has put a heading on my table, but it has also put the label on the axis along with the unit. Let's do the same thing for the y column. Instead of y, we now want to be calling that electrical resistance. And the unit for that is milliohms. So again, our data table now has headings, the graph has the axes labeled. The next thing for the graph is we always want a correct title on it. And the format for titling a graph is y versus x, or independent variable versus dependent variable. To put the title on the graph, we're going to go to this tool, which is the graph tools, and when you click that, down at the very bottom of the menus, we get edit graph options. And the first graph option I'd like to edit is put in a title. And I want that to be electrical resistance versus metal temperature. And when I X out, notice my graph is now set up. So I've got the axes labeled correctly. I've got the title. Notice that right now my scale on the axis is just from 0 to 1 because there's no data in it. But as I start entering the data, the software will automatically adjust that scale so that it shows most appropriately. Sometimes you don't want the scale to be adjusting automatically, and you can turn that off if you like. And again, go to the manual, and it'll tell you how to do that. But I typically leave it alone, just let the software adjust it automatically. The data, to put it in the data table, I can copy it and paste it from my word processing document and paste it over here, or I can just type it just about as quickly, and in this case I'm going to go ahead and type it. So when the metal temperature was 0, the electrical resistance was 64.9 milliohms. when the temperature was 10, resistance was 67.7. Oops, 67.7. And I can just go ahead and type these all the way down. 30, 73.3, 40, 76.1, 50, 78.9, 60, 81.7, oops, 70, 84.4, 80, 87.3, and finally when the temperature is 90, the resistance was 90.1 milliohms. Okay, so notice that the data all is plotted, and you probably noticed that as I was typing the numbers in, the data points were being put in the table as the data was being entered, and the scale was adjusted as well. The next step, once we have this graph plotted, is to find out how the variables are actually related. That means what is the equation that describes how these things relate to each other. For that, we need to put in a best fit line. In this assignment, they'll talk about how the best fit line is not always a straight line. Sometimes it's a curve. The relationship could be linear, it could be an exponential or power relationship, it could be an inverse relationship. But here, when we look at the data, it's fairly obvious that these data points are falling in a straight line, so this is a linear relationship. If I now go again to the graph tools, one of the graph tools is to apply a curve fit. And when I do that, I have several choices. I can put in a linear, which is a direct relationship. I could also choose a power, which is an exponential relationship. I could choose an inverse. I could choose a quadratic, which means there are a couple different things going on at once. And in this course, those four are the only ones that you'll ever use: linear, quadratic, power, or inverse. You can play with those others sometimes to see what they're used for, but those are the ones that we'll be using in this course. So since this is a linear relationship, I just say linear and say apply that, and it put a linear best fit line on the data, and it has calculated the equation that describes the relationship suggested by that data. So this is a direct relationship. Y equals mx plus b is the generic equation, and that means since y is the electrical resistance and x is the metal temperature, it means that the electrical resistance can be found by taking whatever the metal temperature is, multiplying by 0.2797, which is the slope of this line, and adding the y-intercept, which is 64.9, which is what the resistance was at the very beginning of our data. These other two things are correlation values, which just tell us how closely the data points actually fall to that best fit line. If this R correlation value is 1, that means it's perfect. All the data points fall exactly on that best fit line. Normally the data is kind of scattered a little bit. Some of the points are a little bit above the best fit line, some are a little bit below. So it's rare that you actually end up with a correlation of exactly 1. Okay, so that is how you get this graph plotted and get it all looking in correct form and have the information that you want. The next problem you have to overcome is, now how do you get that graph over into your lab report? Well, over here on the left, I've got another document opened up. Behind here, I've just got a blank word processing document. And suppose this was my lab report, and I wanted the graph to go in right here below this line, where it says I want the graph to go directly below this line, and my cursor is blinking. Well, this word processor, this could be anything. This could be Microsoft Word. I'm working in Pages because I'm on a Mac at the moment. You could be working in Google Doc. But whatever word processor you're in, you now want that image of that graph at that particular location. In most word processors, the way that you do that is to export the image as an image file, and then in your word processor, you import that image file in, and then you can put it wherever you want it in your document. So over here in graphical analysis, I need to take this software and export an image or a picture of this graph. To do that, I go up here to the File menu, and one of the choices will be to export. When I click export, I can do it as either a .csv, now that's just a data file, so we don't want to do that, or a graph image. So I'm going to click graph image, and I'm just going to leave the name here, but I could name it anything that I wanted. And I'm going to put it out here instead of in my documents folder. I'm going to put it out on the desktop so I can find it quickly and easily for this example. So an image file of that graph has now been saved out on the desktop of my computer. If I want that image file to be put into my lab report right here, there are several ways I can do it. I think Microsoft Word, you insert an image. In Google Docs, I think it's insert an image as well. And here I'm going to choose insert, and I'm going to choose what I want to insert. And the thing I want to insert is that graph file right there. And I click insert, and there the graph is. So we now know how to set up the graph, put all the data in, get the axes labeled, get the titles in, and get the graph into your word processing document. With that, you should be able to do everything that you need to do in the course, and have a good time.